In this video, we're going to look at 0.9 recurring, so that's 0.9999, so on and so on, and whether or not that is actually equal to 1. So we can see very quickly that it's going to get close. Each time we add another 9 onto the end, it's going into a smaller decimal place, it's getting closer to 1 without actually getting larger than it. So it seems like it might make sense, but are they actually equal? Well, let's take a closer look. Let's think of 0.9 recurring as a sequence being added together. So 0.9 plus 0.09 plus 0.009, so on and so on forever and ever. Well, this sequence, we can rewrite it as 9/10 plus 9 over 10 squared, so that's our 0.09, 9 over 10 cubed, and so on, where every term is just 9 over 10 to the power of n, where n is a whole number. And we can rewrite this as a sum. So this is a sum from n equals 1 to infinity of 9 over 10 to the power of n. So all this means is that we're starting with n equals 1, that gives us 9 over 10. Then we're adding the same expression where n is equal to 2, so 9 over 10 squared, and so on until infinity. And what we can see here is that we've got a geometric sequence. So this is a sequence where each term is being multiplied by the same amount to get to the next term every time. And we're starting with 9 over 10, which we're going to call a. And if we say r is the ratio between each of these terms, so a tenth, that's what we're multiplying 0.9 by to get 0.09, we're multiplying that by a tenth to get the next one, and so on and so on. So for that a and r, the sum to infinity of a geometric series, so what they'll always add up to, is going to equal a over 1 minus r, as long as r, the ratio, is between minus and positive 1. If you haven't seen this before, check out my video on how we find this formula for the sum to infinity of a geometric series, because this is what we're going to use here. So now we've got our formula, we've got our a, we've got our r, let's substitute them in. So our sum to infinity is going to equal a, which is 9 over 10, the first term, all over 1 minus our ratio, 1/10. Well, the denominator there, 1 minus a tenth, is also equal to 9/10. So we've got 9/10 over 9/10, which is equal to 1. So we've just shown that 0.9 recurring is actually equal to 1. They are the same thing. If you've enjoyed this video, don't forget to subscribe or check out more of my videos by clicking on the links here.